For this explore, I will be using a Suan-pan 2.5 abacus to demonstrate the multiplication of 144 times 9,233. The way multiplication usually is implemented on the abacus is that we divide the full function into its component sums. So we will start by multiplying 4 times 9,233 by each of its digits. So 4 times 3, 12, 4 times 3, 12, or 4 times 30. So we are moving one decimal place. Next, we move another decimal place, and 4 times 2 is 8. And lastly, another decimal place, 4 times 9, 36. So we have this first digit. Now, since it's 144, the 4 will be just adding, but one decimal place shifted. So I will use a sheet working in reverse. So I know, for example, that here I will add 3, and the next column tells me that I have to add 3. Similarly, we add 6 here, we add 9 here, and here we see why the 2.5 abacus is so useful compared to the 1.5, in that here we have a remainder, that an excess that is already expressed in the abacus. So instead of having to manually always carry it in our minds, we have this f here, so we subtract 10 and we increase 1 here. Same thing here, we have an a, so we subtract 10 and increase 1 here. Similarly, we come back to the 9, to which we add 3, we add 5, subtract 2, then again, subtract 10, add 1, and lastly, we will add the 2. At this point, we have done the first two digits, and we are missing the last one, which is 100 times 9,233. Similarly, now we will be starting not one, but two places from the start, because we're multiplying by 100. So we add 3, we add 3 again, we add 2, and lastly, we add 9. Which gives us the final result, which is 1,329,552. As we see, there is a very useful feature in being able to carry a little bit of the excess of the sums when they go over 10, and it's useful in that we minimize a little bit of our errors by having the physical apparatus have the calculations for us.